C4 the hyperbolic functions. Now these are inspired from trig functions. You recall from the last class we had these formulas. We had the cosine of theta is equal to e to the I theta plus e to the minus I theta over 2. And we had the sine of theta equal e to the I theta minus e to the minus I theta over 2I. Now, these equations inspire us to consider a new function called hyperbolic cosine, or cosh, of x. We are going to replace the I theta with x. E to the x plus e to the minus x over 2. And then for the analogous function for the sine, we're going to say hyperbolic sine, or the sinh of x, is e to the x minus e to the minus x over 2. So we're going to throw that I away. These are the new definitions for new functions, the cosh and the sinh. Now, the first thing I'd like to do is find an analogous equation to the cosine of squared theta plus the sine squared theta equal to 1. And to do that, I'm going to square these. So let's go ahead and square the cosh. And that's going to give us e to the x plus e to the minus x over 2 squared. And I'll write that here on the next line. The cosh squared of x is, we're going to have in the numerator e to the x times e to the x, in other words, e to the x squared. So that's e to the 2x. And then for the cross terms, we're going to have 2 times the product of these two. But e to the x times e to the minus x is equal to 1. And there's going to be 2 of them, so that's going to be 2. And then the last term here is e to the minus x squared. That's going to be e to the minus 2x. And that's going to be over 4, the 2 squared. Now, looking at the sinh squared, we're going to have the same thing, except the cross term is going to have a minus sign. Because if we square the sinh, we'll have the first term squared and the last term squared. The minus sign won't matter because we're squaring it. The only thing is going to be the cross term. So we just copy this again. E to the 2x minus 2 plus e to the minus 2x over 4. And now we see that if we subtract the bottom one from the top one, we're going to get 1. Because then this one would cancel this one, this would cancel here, and you'd have a minus 1/2, and this is a plus 1/2, but it's just, if you subtract the minus 1/2 from the plus 1/2, you're going to get 1. So that's going to give us the cosh squared minus the sinh squared equals 1. And that's our analogous equation to the cosine squared of theta plus the sine squared of theta equals 1. This one right here. Analogous to this equation. Now, at this point, we should take some time to try to understand what these new functions do. In other words, let's sketch the graphs. So to do that, I'm going to look at my x and y axis here. This is the x. Going up here is y. And we're going to sketch 2 functions I'm going to write these functions here closer to the graphs. So I'm going to write down the cosh of x is equal to e to the x plus e to the minus x over 2. And then over here, I'm going to write the sinh x equals e to the x minus e to the minus x over 2. Now, if I put in 0 for x, then the sinh is going to be 0. And the cosh is going to be e to the x, if x is 0, is going to be 1 plus 1 over 2. It's going to be 1. So let's mark 1. And then if we look at the cosh first, as x gets bigger and bigger, what's going to happen? Well, what happens here is that if x gets bigger and bigger, then e to the minus x gets smaller and smaller. So as x goes from 0 out to infinity, this drops out. And we wind up with e to the x over 2. So basically an e to the x type function, that's exponential. So I'll go ahead and sketch that in like this. And on the other side, you're going to have the same thing. In other words, if x becomes minus x, the numerator basically stays the same because this one flips the minus x, this one flips the plus x, and it's the same. Now, remember that the cosine is an even function, and here the analogous function we have here with the hyperbolic functions, this is even function also. So that means what's on the right, it reflects about this axis like a mirror onto the left. So this is a sketch of the cosh. Now what about the sinh? Well, for the sinh, notice that if x goes to infinity, then this drops out just like it dropped out over here, and you get the same thing. You get e to the x over 2. So that means this is going to be overlapping. This is the same basic when it's far away. And remember, when x is 0, you have 1 minus 1. So you're going to have, down here, you're going to have 0. So you're going to have something like this. Now, this is an odd function, just like the sine is an odd function. If x goes to minus x, then the minus x is on this side, the plus x is on that side. But then the minus sign is hitting the plus x instead of the minus x. So you see that this is an odd function. And that means that this graph down here is going to be on the negative side. It's going to do something like that. All right. It's an odd function. Now I would like to do one more, and that is the hyperbolic tangent. The hyperbolic tangent of x is the sinh divided by the cosh, and that's going to be e to the x minus e to the minus x over 2, but that's going to cancel the over 2 down in the denominator. So we have this one, e to the x plus e to the minus x over 2. They're going to cancel. So you're essentially going to have this numerator divided by that numerator. So what happens here? Well, this is interesting that in this case, when x goes off to infinity, these terms drop out, and we're going to have 1. So here, I shouldn't have written that there. In other words, we're going to approach 1. We're going to start at x equals 0, which is 1 minus 1. We're going to start at here, but then we're going to go out to approach this line, which is the line where y is equal to 1. And this is an odd function because you have an odd function divided by an even function, so the net will be odd. So that would be here marking, say, the minus 1 down here, and a dot, dot, dot like that. Then we would come down here with something that does this. So the sinh of x is this red one here, and the hyperbolic tangent is this green one, and the cosh is this blue one. So we're basically going off to 1 as we go to infinity, and down here we're going to -1. Very, very nice to see these plots. Now, what about taking the derivative? All right, let's take the derivative of at least the cosh and the sinh. So if we take the derivative of the cosh like this, we want the derivative here of e to the x plus e to the minus x over 2. Well, the derivative of e to the x is e to the x. So this 2 is gonna hang around. I'm gonna leave the 2 down in there, and I'm gonna get e to the x. Now the derivative of this one would be, you would take the derivative using the chain rule, would be e to the minus x times the derivative of what's up there with respect to x, which is -1. So this is minus e to the minus x, and that is wild. That is the sinh. Now, if we take the derivative of the sinh here, you can see this is going to be a very easy result to calculate. Everything's going to be the same except there's a minus sign in the middle there. So this is going to be e to the x plus e to the minus x over 2. And that's the cosh. Let's pause here for a moment and look at these derivatives. Now, the derivative of the cosh is the slope. Well, if you look at the slope of the cosh, it's 0 right here at when x is 0. When x is 0, the sinh is 0. That checks out. And as you go farther and farther to the right, when x gets larger and larger, the cosh becomes e to the x over 2. But the derivative is e to the x over 2. So you see that the sinh, the red curve, blends in with the cosh curve. That's really neat to see that. Now, if you look at the derivative of the sinh, well, here, looks like it's kind of 1. So let's put in 0 for the x, and you have e to 0 plus e to 0. That's 2 over 2 is 1. And that's what it's saying here. The cosh of 0 is 1. And that corresponds to the slope of the sinh at x equals 0. Then, as you get larger and larger with x, you find that the sinh blends in with the cosh as they both become e to the x over 2, e to the x over 2 because the e to the minus x gets smaller and smaller. So they blend in, and they are essentially the slopes of each other because e to the x over 2 is the slope up here, and the graphs up here are e to the x over 2. So everything checks out nicely. Wow. Now, back when I was a freshman in college, I had a friend that pointed this out to me in sort of a joke. Let me go ahead and write these out first, and then I'll tell you what he told me. All right. He said the derivative of the cosh is a sinh, and the derivative of the sinh is gosh, is what he said. Okay, I'll leave you with that. See you next time.